My milling machine is down for maintenance right now. One of the things I'd like to do while it's apart, I'd like to try and reduce the vibrations that travel from the head down through the column and into the table. I'm going to do that. I'm going to try and do that by filling the column with some epoxy sand. If that interests you, stay tuned. We'll get started. This is the rack that allows the head to move up and down. It's not physically attached to the column. It floats so that as you rotate the head around the column, it can move. It fits into a chamfer in the top cap, and that's what holds it in place. That top cap is only held in place with a single set screw. And I've noticed that as you use the rack, move the head up and down, that this thing tends to skew, and then it binds as you move the head. Really, a single set screw is insufficient to hold this in place. So what I want to do, I want to drill a hole in this, and I want to run a length of all thread all the way through the column, and that all thread will then bolt to the table. So when it's done, I'll have a nut on top, a nut on the bottom of the table. When I tighten it down, this cap will be held firmly in place. I don't want the all thread embedded in the sand that I'm going to put in this column. I want to be able to remove it. So I'm going to insert a piece of tubing in through the column that all thread can fit through. I want the tube perfectly centered inside the column, so I designed and printed a pair of bushings. The top one fits perfectly over the tube, and then when installed makes a tight seal that should keep the epoxy from leaking out. The bottom, I added holes so I can press it into the epoxy and help hold it in place. I'm using some 1-to-1 epoxy, so this is 1 part epoxy resin to 1 part hardener. This is sold as tabletop epoxy. I got this for $55 for the gallon online, so it's half a gallon of resin and half a gallon of hardener. When you mix them together, you get a gallon. I mix that together in one of these disposable 5-quart buckets. I went with this one because it's graduated, so I can see how much resin and how much sand I put in. If you're really careful, you can break out the epoxy and reuse the bucket when you're done. So here's the recipe I used. For epoxy, I use 64 ounces per batch. That's 32 ounces of resin and 32 ounces of hardener. For sand, I use 16 pounds per batch. That gave me a ratio of about 80% sand to 20% epoxy. When mixed together, this has the consistency of homemade peanut butter. This is what was left in the bottom of the bucket when I was done. I let it cure overnight and then I broke it out with a hammer. I was curious about the density of this mixture, so I dropped the epoxy sand into a bucket of water to determine its volume. Then I weighed the pieces. Using some simple math, I calculated the density of this epoxy sand mixture at 89 pounds per cubic feet, or about 1,425 kilograms per cubic meter. That's roughly 20% the density of the surrounding cast iron. So here's what this looks like after I cut it apart with the wet saw. There's one void right here that I think was caused by an air bubble. Otherwise, the sand is really well mixed in and it's consistent throughout the depth. I'm really happy with how this turned out. I think it's going to be really good. I'd originally only planned to do the column, but it turned out so well I decided to do the base. The base was a bit more difficult, specifically the areas around the lead screw. To protect those from epoxy, I cut a piece of 3-inch ABS pipe in half. I then used a file to notch around the ribs in the casting. I pushed that in place and I sealed it to the base with some caulking. The column took about half a batch to fill it up, or about 8 pounds of sand. The base was considerably more. I had to mix up 3 batches to fill it up, or roughly 48 pounds of sand. When it was said and done, I used about 60 pounds of sand and about 1.5 gallons of epoxy to fill the base and the column on this milling machine. So this is cured overnight. It's been about 24 hours. I'm going to remove all the bolts and the plugs that I put in here. Hopefully I can still get them out. I'm a little worried I may have glued some of them in place. These two that you see here, so I drilled some holes in that pipe and I used these to create a tunnel. So basically when oil gets into that pipe that I added, this gives them somewhere to drain. So I'm going to grab a wrench and let's get these taken off. So this is what that looks like with all those bolts removed. Anywhere I had bolts come through or I had something that I needed clearance for, I added one of these tubes. So these tubes are embedded in the epoxy, but they protected the threads or the bolt holes or any other clearance holes from getting filled up with epoxy. So this is the piece of metal I bolted to the column area. I coated it just with axle grease before I bolted it down, and that acted as a seal. It protected this machine surface from epoxy, but it also prevented this epoxy here from adhering to that plate. I think that looks pretty good. This tube here is to allow that tube I added to the column to pass through. So the all thread will come through and it will pass through this and into the table. Some of the tubes extended too far out of the epoxy and they were above the feet of the base. You can see that when I lay a straight edge across that this one is too high. To fix this, I laid a washer over each tube to act as a guide, and then I used a flap disc to take them down to the appropriate level. All right, that looks really good. The all thread needed to be 42 inches long to fit in the column. I had to buy a 6-foot length and cut it down. So I bolted the base to the table and I've bolted the column to the base. I was going to insert the all thread and bolt it to the table. Unfortunately, it's just a little long, so I can't get it in from the top. It hits the ceiling. So I tried from below, and it's the same story. It's just a little bit too long. So it looks like I have to insert the threaded rod into the column and then put the column on the base, then bolt it in place. I just don't have enough room to drop the all thread straight in. Fortunately though, when I built this table, I included some lift points, so it was easy enough to lift the table up and insert the threaded rod from below. The top cap on this machine is made out of cast iron. To ensure I got the hole in the center, I chucked it up, I drilled the hole using the lathe. I've installed the top cap and the all thread. Everything's tightened down. It went together really well. Everything fit nicely. I'm really happy with how it turned out. We're not going to be able to test it tonight. I am still waiting on some spindle bearings, so I can't put the mill back together tonight to test it. But in a couple of weeks, expect a video from me where we'll put the mill through its paces and we'll see if that epoxy sand was a worthwhile thing to do. My initial reaction is that it was probably a waste of time. At 20% the density of the cast iron, I just don't think that epoxy sand is dense enough to really do much. But we'll put it through its paces, we'll test things out, maybe I'm wrong. So that's it for today's video. I hope you enjoyed watching it, or at least I hope you got something out of it. Thank you for watching, I'll see you later.